Welcome to qnawire.
So here we know that the electric field would be equal to its uniform surface charge density divided by 2 times the permittivity of free space. This would be equal to 2.34 times 10 to the negative 9th coulombs per square meter, and then divided by 2 times the permittivity of free space, 8.854 times 10 to the negative 12th, and the unit here would be coulombs squared per Newton per square meter. And this is equaling 132.1 newtons per coulomb. And so we can use the Newton's second law and find the acceleration in the y direction. This would be equal to the electric field, the magnitude of the electric field times the charge divided by the mass. And so this is equaling 132.1 newtons per coulomb multiplied by the charge of 1.602 times 10 to the negative 19th coulombs divided by the mass of 1.673 times 10 to the negative 27th kilograms. And we find that the acceleration in the y direction is 1.265 times 10 to the 10th meters per second squared. We can then simply use kinematics to find the final velocity in the y direction. This would be the initial velocity in the y direction, not squared, but my apologies, I'm using the wrong kinematic equation. Even simpler than this, Vy final equals Vy initial plus the acceleration in the y direction times t. We know that the initial y velocity is going to be 0, and so this would be equal to 1.265 times 10 to the 10th meters per second squared multiplied by the time of 5.00 times 10 to the negative 8th seconds. And we find that Vy final is giving us 632.7 meters per second. And so we can calculate the final velocity, magnitude of the final velocity. And so this would be equaling square root of 970 meters per second quantity squared plus 632.7 meters per second quantity squared. Extend the square root. And we find that the magnitude would be equal to approximately 1.16 times 10 to the third meters per second. This would be our final answer. That is the end of the solution. Thank you for watching.